Okay, please begin your presentation.
Yes, thank you. Hello, everyone. Today I'm going to talk about the role of artificial intelligence in the Internet of Things and cybersecurity as well. And in the first here, in the context, the authors basically in this paper talks about cybersecurity, Internet of Things, artificial intelligence, and how they all relate to each other. And also they're trying to provide a comprehensive review of cyber attacks against the IoT devices, as well as provides a recommended AI-based methods in a way to protect these devices against these attacks. As we all know, in the past recent years, the use of the Internet of Things has increased exponentially. And also, cybersecurity concerns have increased along with it. Now, on the cutting edge of cybersecurity, we have AI, which is basically used for the development of complex algorithms to protect networks and systems, including the IoT systems. Now, however, cyber attackers as well have figured out a way also how to exploit the AI and have even began to use adversarial AI in order to carry out cybersecurity attacks on the IoT devices. Here, second, we're going to talk about some methods of attacking the IoT devices. And first, here on this figure, it's just showing a basic breakdown of a common Internet of Device system. And due to the lack of security in many Internet of or IoT devices, also cyber attacks have found many ways to attack IoT devices from many different attack surfaces. And those attack surfaces can vary from the IoT device itself, from even like its hardware and software, the network, as well in which were the IoT device is connected to, and even the application with which the device interfaces. And most of the attacks that we're going to discuss in this paper is going to occur at the network, gateway, or the cloud data server connection, because these connections are generally where the IoT security is most lacking. Before the IoT attackers even attempt the cyber attacks on any IoT device, they often, try to study the device and to try to identify that device vulnerabilities. Usually, this is done like by buying a copy of the IoT device they're targeting from the market, and then they try to basically reverse engineer that on that device to just create, a test attack to see what the output is going to be obtained and what avenues exist to attack the device itself. And in order to counter reverse engineering, it is definitely important for the IoT devices to have a hardware-based security. And the application processor usually consisting of sensors, actuators, power supply, and even connectivity should usually be placed in a tamper-resistant environment, or even a device authentication can also be done with the hardware-based security, so that the device can prove to the server it is connected to that and it's not just fake. So here we basically starting with the physical attacks, and this is one of the methods that they use to attack an IoT devices. And usually often on a low-tech type category of attacks, physical attacks come under that, and in which usually the hardware of the targeted device is used to the benefit of the attacker in some way. And there's also including two different type of physical attacks, and can be an outage attacks and even a physical damage. And an example here, it will be the malicious code injection, of which includes an attacker plugging a USB containing a virus into that targeted device, and then object jamming, in which signals jammers are used to block or even manipulate signals to put away by the device itself. Second here, we have man in the middle. And this one also considered one of the most popular attacks on Internet of and the IoT devices. And in the second figure here, it just shows us a basic example of the MITM attacks between like a client and a server. And usually the man in the middle attack happens like where it's like intercepts the communication between like two nodes, like the client and the server, and it will give a permission or will allow the attacker to take the role of a proxy. And it can happen even on like different connections, such as like a computer and a router or two cell phones, but it's most commonly happens on a server and a client. In regards to the IoT, the attacker usually performs this type of attacks between the IoT device and the application with which it interfaces. And it comes into two common modes. We have the cloud pooling and we have the direct connection. A good example here on this type of attack will be like if you have a smart refrigerator that could display, you know, your Google Calendar. It might seem like it's a harmless feature, but honestly, like the attackers found that the system did not validate the secure socket layer certificates, which honestly allow them to perform this type of attack and then steal your Google credentials. So that's like a big problem, basically. Another kind here of a common attack we have here on IoT devices is called botnets. And it's recurring like on many devices, basically to create botnets and then launch a distributed denial of service attacks. And this type of denial of like service attacks is characterized by an orchestrated effort to prevent legitimate use of a service. And it can be used from multiple entities to be able to achieve this goal. And it usually aims to like overwhelm the infrastructure of the target service and then disrupt the normal data flow. So basically, you know, it can happen to like even shut down the machine or the network then between the two, so between the IoT devices and the internet connection. And usually the DDoS attacks generally go through a few phases. We have like recruitment, exploitation and infection, communication, and then attack. And here basically shows just a common command structure where you guys can see that the attacker's master computer sends a command to one or even more infected commands and control centers, who each control a series of zombie devices, and those zombie devices can then attack the targeted or the victim device. Third, here we're going to talk about the artificial intelligence in cybersecurity. So in order to dynamically also protect these systems from the cyber threats, also many cybersecurity experts are turning to AI. And what is mostly common used for intrusion detection in cybersecurity. And usually it's done by analyzing the traffic patterns and then looking for an activity that is characteristics of an attack. When it comes to machine learning, we have two main kinds of. We have a supervised learning and an unsupervised learning. But one popular machine learning algorithm here they're mentioning in this paper for cybersecurity is which seeks to basically classify the data based on the Bayesian theorem, where it's basically an anomalous activity that assumes to originate from independent events instead of one attack. And this one considered like a type of supervised learning algorithm. And once it is trained and has generated its classes, it basically will analyze each activity to just determine the probability that is anomalous. As third one here, we talk about the decision trees, and it's basically a type of AI that helps or creates a set of rules based on its training data samples. And an example of this approach in cybersecurity is detecting the denial of service attacks. And it's usually done by analyzing the flow rate, size, and then like duration of the traffic. So for example, if the flow rate is low, but the duration of the traffic is long, it is likely considered as an attack. And this figure over here, it's the decision tree also showing that it can also be used to detect command injection attacks in robotic vehicles by basically categorizing the values from the CPU consumption, network flow, and the volume of the data written. And this technique is popular because it's like intuitive in that what the AI doesn't as well. Considering, the anomalous traffic is known to the developer. But additionally, once an effective series of rules is found, the coolest thing here about the AI can analyze the traffic in real time, providing an almost immediate alert if like unusual activity is detected. Here in the supported vector machine, they are basically like a type of like an extension of linear regression model that helps locate a plane that separate data into two different classes. And it even can be separated into more than two classes by just using more than one plane. This technique is used to analyze the internet traffic pattern and separate them into their components, such as HTTP, FTP, and so on. It is considered also a supervised machine learning technique, and it is often used in applications where attackers can be simulated, such as using network traffic generated from training and training data. And here, finally, we're going to talk about the AI to attack the IoT. So how basically the cyber criminals also have began even to using AI and or malicious AI to aid and help those attacks on the IoT systems. And often it's done by like thwart the intrusion detection algorithm in the case of the Internet of Things devices, or even attacking the beneficial AI in such a way that they make that AI works against its own system. And here, when it comes to automation of vulnerability detection, usually machine learning can be used to discover vulnerabilities in different systems. While this can be also like useful for those trying to secure a system to search for vulnerabilities, also attackers can use this technology to locate and exploit the vulnerabilities in their targeted systems. And as we all know, like the technology source and usage, especially the technology with low security standards, such as the IoT devices, also the number of vulnerabilities that attackers are able to exploit has soared as well. And, like as developers are able to use these detection tools as well, and it should be like, noted that developers are having the disadvantage here, because when it comes to securing a system or a device, they must find every single and correct vulnerability that could potentially exist on that device. While the attackers, they only need one, they need to find one just to, making that automatic detection a really valuable tool for the attackers themselves. Fuzzing here at its core, it's like basically a testing method that generates random inputs, and basically this random inputs then can cause the target software to crash. And it can be divided into dumb fuzzing and smart fuzzing. Basically, the dumb fuzzing generates the effects by just randomly changing the input variable. It's a fast changing and simple tool, but when it comes to the smart fuzzing, on the other hand, they generate input values that is suitable for the target software. It's based on the software's format and error generation. And when it comes to the input attacks here, it's basically just when the attacker alters the input of the AI system in a way such that causes the AI to malfunction, basically, or just give an incorrect outputs. And the input attacks are often like categorized based on where they rest on two axes. Basically, they are the perceivability and the format. And the perceivability here on the input attack, it's basically the measure of how noticeable the attack is to the human eye. While the format is measured on how digital versus physical the attack it is. And basically altering targets such as like deforming, removing part of, or even changing its color, or even adding to the target, such as like affixing the physical tape on, like, or adding digital marks. These all considered a type of perceivable attacks. Where conversely, on the imperceivable attacks, they are invisible to the human eye. So this can include things such as like a digital dust, which is basically just a small amount of noise added to the entire image that is not visible to the human eye. But it will be significantly enough to an AI to change its output. And imperceivable attacks are generally like more of like a security risk considered. But a good example on the input attacks specific to basically the IoT, like smart cars, or more broadly will be like a smart cities. So an example would be like just placing a piece of tape in a specific way on a stop sign. It will be honestly enough for an algorithm to not recognize the stop sign or even classify it as a green light, and which is going to be harmful for passengers in the car. And on a large scale, could alter like the traffic pattern detectors in a smart cities. So it's like really a big problem. So additionally, the noise-based input attack would also cause this smart assistant to malfunction even and carry out unintended commands. And here in the summary, just we're showing basically some of the IoT attacks that are mentioned and methods of protecting against these attacks. So when it comes to physical attacks, a method of protecting against this, it will be like using a tamper-resistant hardware or even hardware like these trust anchors. And when it comes to the man in the middle, we can run your regular software updates, use proper firewall configuration, strong encryption, avoid insecure Wi-Fi. For the botnets, basically, we can run regular antiviruses, scans, avoid suspicious email attachment or downloading, from suspicious links. Run also regular updates. For fuzzing, we can even, like we do, properly sanitize any input, limit the allowed inputs as well. Those type of limits will help against these type of the attacks. As a conclusion, this paper basically explores popular techniques to attempt to disrupt or compromise the IoT and explains at the surface level how these attacks are carried out on the IoT devices. And the ultimate goal of this paper was like just to help and create a resource for others who are researching these prevalent topics by presenting a summaries of and making connection between relevant work that covering different aspects of these subjects. Thank you.